And this is Craig Double, and this is part two of Lab 6. And I'm going to go ahead and show you in this video a demonstration of how to take a tuning fork, basically, or something that emits sound at a certain frequency. In this case, we're using 384, it says on my tuning fork. And we're going to see where we get the loudest, we're changing volume, where it's the loudest in this tube as I move it up and down this column of water. So in the lab, it has you set your level at 17 centimeters in the glass. Again, you should leave the water sit for quite some time for it to come to equilibrium. I let mine sit overnight. And if you're worried about water evaporating, you just get another container off to the side, such as a Pyrex container or whatever, and let it sit overnight as well, so you can add water if necessary. All right, so I've already done the experiment just to kind of make sure I know what the heck I'm talking about here, and just to kind of see and understand how it all works. But hopefully this helps you out. So as you can see, I've shown you my table and how it works. One of the things I highly recommend is that you go ahead and set up. So if you look here, all this data in columns, the first 3 or 4 columns is just data you enter. And then I set up formulas based on the equations from the lab. So this is the one for wavelength, so 4 times, and then whatever value you get for your the length. And then you have 0.3 times. In this case, the H column would be the inner diameter of the tube. All right, and all these measurements that you do take, and then over here I got the estimated speed. So it's just the wavelength times the frequency, and then theoretical speed of sound. There's the equation right there. Okay, and then percent error, it's in the book. You should know that one by now. All right, so all the rest of this data you put in here, it is necessary that you do get accurate data. I did have a digital thermometer, but it broke on me. I accidentally dropped it in the water, so it doesn't work anymore. So the lab kit does come with the this thermometer here. It works just fine. I ended up checking the measurement of my water again, taking the temperature. I got 20 degrees Celsius still. So I'll show you what I got, how I got the results up here in the first column. So again, a 384 hertz tuning fork, and I'll show you where we get to approximately 0.21 centimeters, or in this case 0.21 meters when you convert it, where it gets the loudest when using a tuning fork. So here it goes. So that's the first change in volume, and you can hear that one right there. So it gets louder. It's about 2.1 centimeters. So that's the loudest. And then what I also noticed is as I went down, around the 10.5, there was also a change in volume. So I asked myself, and I'm not really 100% sure if I really understand why, but I think based on in the bottom of this video, I'll show you a link and it explains this lab a lot better. There's a guy that demonstrates and does a lot better job than I do. But I think what's happening is that you'll hear down here the first antinode of the wave. That's where I think it occurs. And then down here, there's the second or the next antinode that's hitting the walls of the pipe, and it's the point where there's the most compression of the molecules of air inside the pipe are, so the sound's going to sound a lot louder. So it's all based on a standing wave going through the pipe, and you're just trying to figure out where the antinode is, I think. Anyways, I take that data, I had 0.21, and I did markings on my tube just to make it easier for measuring. I would highly recommend that. You can use an assistant and then try to measure it while you're holding it still in the water. It's kind of difficult, and you can do it with your measuring tape, but I recommend just marking off your pipe every centimeter. You can even do 0.5 if you want even more precise measurements. But that's that. So that's the 384 frequency. And as you see, I just typed in all my data. I had all this set up before, all my formulas, and I came out. I was actually surprised. 3.14 percentage error. Came out with an estimated speed of sound of about 332 meters per second. All right, so that was with the tuning fork. So I kind of got a little motivated, and I did try different tones, and it's actually pretty easy. I did also down here, I show you the 1 meter pipe. And if I highly recommend, if you do the 1 meter, you want to cut your pipe or tube probably a couple centimeters longer. At 1 meter, it's hard to hear the change in volume if you're exact, and you have to hold the tube just at the edge of the water to really get any kind of an effect at the bottom of the tube. But if you use different frequencies with the longer tube, you can actually hear a difference. You just have to find the right ones, because as you can see here, I experimented with 440 hertz, and I tried 500 hertz, and that was with the short tube here, and found that the higher the frequency, the length from the bottom of the water to the top of the tube gets shorter. So I'll demonstrate here using this tone generator that you can just use online. It's from Sinalski.com. I'll just show you it. All right, you can go to that website, or just type in Google online tone generator, and it will pop up a tone generator for you. So we're going to start with 700 hertz. Let's see what 700 hertz does. And I apologize if this sounds irritating, but here's where it goes. Here we go. Oh, I'm going to reset. Let's try that again. All right, so we're going to set our tone generator to 700. Come on. There we go. Okay, we're at 700. And let's see what happens at 700. Hit play. So if you notice, when the tube's farther out of the water, as I get down, my length gets shorter, shorter, shorter. And I see at approximately 1 centimeters, maybe 1.5, the volume increases greatly. So that was 700 hertz. So I got 1.5. So let's check out 1.5 here. I'm just going to put it in my data table for 700 hertz. 0.15. Oh, that's not it. 115. Okay, so that's 0.115 meters when converting it. And then I had the inner diameter hasn't changed on my short tube. It's still 0.021 meters. And we come out, wow, look at that. All right, so there you go. A little more practice and checking it out and doing some more experimentation with different frequencies can help you come out with better results. I got an error of 0.98. It's actually pretty surprising. Okay, so you could do this with different frequencies, and if you're going to use the long tube, it's definitely the effect is greater because the tube's longer, and I'm using a 5-gallon bucket for that one, so it gets a little bit louder. But that's it. That's it for this lab. Again, I will have the link to our professor, compliments of the professor. They put on there a good lab video that kind of explains this in more detail. And if you don't agree with something that I talked about with the anti-nodes or anything, please leave some comments. I'd like your feedback. That's all I have. Have a great evening.